So now I just want you to present how we normally solve, like, suppose you are given a source to produce some bipartite state for AB. So you know, you have a photon source of your quantum computer. It emits some photons, and thanks to it, you have rho AB bipartite states. And you're trying to know if this state is entangled or not. So yeah. Mm, the strategy normally is like you can use is to measure copies of the states and use a measurement statistic. Normal strategy: measure different copies of the states and use the measurement statistic to know whether it is integral or not. And more specifically, it could be nice if you could construct an observable W such that trace of rho AB of W is superior to zero for all separable rho AB. So yeah. So it means like if you have this, you have separable stuff. Else, like it means trace rho AB W will be strictly inferior to zero, and it will be entangled. Like yeah. So geometrically, we have like trace rho AB equal W equals C, defining a hyperplane um, that separates the convex sets of separable states from entangled states. Because if it's inferior to zero, it's entangled, and if it is not, then it is not entangled. So basically, you have all the set of density matrices. Um, so you have like a line here, let's say, where the trace of rho AB W equal to zero, and so here it's just inferior to zero, and so that's just the entangled state parts. And here you have like the trace of rho AB W strictly superior to zero, and so it just the separable states that you can represent. Uh, so yeah, it's not here, here, yeah. So entanglement witnesses are hyperplanes that all separable states lie in the half space where trace for ABW is superior to zero, and in the diagrams depicted witness W will be able to detect the entanglement of the entangled states, which is a black dot, as it lies in the half space where the trace of ABW is strictly inferior to zero. Oh yeah, that's. And if you want to know more specifically, like why separable states, it just like why I did not take all of this two into the first states, not the bigger set. It's just because like we have the guarantee that if it is strictly inferior to zero, it's untangled. So here it's integral for this point black, but it does not mean that if it is superior to zero, it cannot be untangled. So it can be untangled here, for example. So it just means that yes, separable and untangled state like from the unstable set of density matrices, but it does not mean that all untangled states relies on the line here. It can be untangled state on the up to. So that's why we have like separable states like being a subset of the stuff when trace of y b is superior to zero, but we have the guarantee that when it's strictly inferior to zero, then it is untangled.